welcome you in the lecture series of Basics of Communication Engineering. It is fourth lecture of this series. In previous lecture, we have discussed about evolution of communication system, type of communication system, and goal of the communication system designer. In this lecture, I would like to discuss about signal, and the outline of this lecture are what is signal, where we will discuss about analog and digital signal, periodic and non-periodic signal. And also we will discuss characteristics of periodic signal. The first characteristic is time domain and frequency domain representation, where we will discuss peak amplitude, frequency or peer, and phase of the signal. And another characteristic is the propagation time and wavelength. After this we will discuss about transmission impairments. The three components of the transmission impairments are attenuation, distortion and noise. And in the objective of this lecture, you will able to explain the difference between analog and digital signals, the difference between time and frequency domain representation of the signal, the sources of impairments and noise, and the attenuation and distortion. So now first we will discuss what is signal. Signal is some kind of information that we want to send from one end to another. The signal xt is defined as a function of time. It can be analog or digital. The term analog refers to the information that is continuous, and digital refers to as a information that is discrete in state. Analog, just like for the analog signal, analog clock, in which second hands gives information in continuous form, whereas in digital clock, time will change sudden from 8005 to 806. So from 805 to 806, there is sudden change in time in digital clock. Sound made by human voice when someone speaks is an analog wave and creates in air, and this can be captured by microphone, whereas data stored in the computer in CD is in the form of 0 and 1. So this is a digital signal. And analog signal can have infinite number of values in over a period, and a digital signal can have only a limited number of defined values in the duration, in some duration. Just like in this duration, this is limited value, but in this duration the signal having infinite number of values. Now second is the periodic and non-periodic signals. Both analog and digital signals can take one of the form, periodic or non-periodic or aperiodic signal. In communication system, we commonly use a periodic analog signal and non-periodic digital signal. A periodic signal is one that repeats itself in time. This means the signal xt will be equal to xt plus t naught, and there is repetition at t naught where for all value of t. Here t naught is the minimum value and it is the period of the signal. And the fundamental frequency, it will be 1 by the period of the signal. For example, if I am having signal xt, it is equal to cos 2 pi fmt, then the time period, it will be 1 by the frequency of the signal. A signal which does not repeat itself after a fixed time period or does not repeat at all is known as a non-periodic or aperiodic signal. And these signals having the condition like xt will not be equal to xt plus t naught. For example, the periodic signals are sine waves, cosine wave, square waves, and non-periodic signals are exponential, rectangular, DC signals, and unit step signals, etc. So you can see this is the analog signal and this is the amplitude, and here the signal xt can be represented as a sine 2 pi f naught t. And on the x-axis this is time, and on y-axis This is the amplitude of the signal xt, and it is maximum value is a, and the period, uh, the time period is where this signal complete one cycle. So this is time period t naught. It is 1 by f naught. F naught is the frequency. So this is the periodic signal, and non-periodic signal is, you can say, this is exponential signal. This is non-periodic signal because one cycle period is infinite, and this exponential e to the power minus alpha t is a non-periodic signal. Now, the characteristic of periodic signals. A periodic analog signal can be classified as simple or composite. In simple periodic analog signal, a sine wave can be decomposed into simpler signals. A composite periodic analog signal is composed of multiple sine wave. A sine wave is most fundamental form of a periodic analog signal. A sine wave can be represented by three parameters: peak amplitude, frequency or period, and phase. The peak amplitude of a signal is the absolute value of its highest intensity and proportional to the energy it carries. For electrical signals, the peak amplitude is normally measured in volts, and peak amplitude of AA battery, the peak amplitude is 1.5 volt. The signal can be represented, this is the analog signal. On x-axis this is time, and on y-axis this is amplitude, and peak amplitude is the maximum amplitude of the signal. And the period and frequency. Period refers to the amount of time in second a signal needs to complete one cycle. Frequency relates to the number of periods in 1 second. Frequency and periods are just one characteristic and defined in two different ways. And just like here you can see, this is the period of the signal. One complete cycle is here. This is the period of the signal, and in 1 second there are 8 cycles are completed, 8 periods in 1 second. So the frequency is 8 hertz, and the period will be 1 by frequency, or you can say 1 by 8 second. Here you can say the frequency and period are just one characteristic defined in two different ways, and they are related inversely. Frequency is 1 by t and t is equal to 1 by f. For example, the power we use at home has frequency 50 hertz. The period of this sine wave, it will be 1 by f, or you can say 1 by 50, or 0.02 10 is to the power 3 millisecond, or here it is 20 millisecond. So this means that the period of the power of our light at home is 20 millisecond. Our eyes are not sensitive enough to distinguish these rapid changes in amplitude. Another way to look at the frequency is a measurement of the rate of change. So frequency is the rate of change with respect to time. Change in a short span of time means high frequency. Change over long span of time means low frequency. What if a signal does not change at all? What if it maintains a constant voltage level for the entire time it is active? In such case, the signal never completes a cycle. That is, the frequency is 0 hertz. So if the signal does not change at all, its frequency is 0. Or you can say, just like DC signal, if it's having constant amplitude, it's not having frequency, so the amplitude does not change over the time, so it is having frequency 0. But if a signal changes instantaneously, in such case the signal period is 0, and frequency, you can say, it will be infinite. Now we will discuss about phase. The term phase describes the position of the waveform relative to time 0. If the sine wave if the wave can be shifted backward or forward along the time axis, phase describe the amount of that shift. It indicates the state of the first cycle, and the phase measured in degree or in radian, 360 degree or 2 pi radian. And 1 radian, it will be converted into 1 degree can be converted into radian. 1 degree, it will be equal to 2 pi by 360 radian, and 1 radian, it will be equal to 360 by 2 pi degree. And a phase shift of 360 means shift of one complete period or one complete cycle. A phase shift of 180 degree means shift of one half of the period, and a phase shift of 90 degree means shift of one quarter of the period. Just like this is a signal sine wave with phase 0 start at time 0 with 0 amplitude. So here at point t is equal to 0, amplitude is also 0, and from this point amplitude is going to increase. This means the sine wave having the phase 0. If these conditions are follows, time 0, amplitude is 0, and from that point amplitude is going to increase. And this is another sine wave with a phase of 90 degree start at point 0. So here you can see at time 0 the amplitude is maximum at this point, and from this point amplitude is going to decrease. So here at time 0 the peak amplitude and amplitude is going to decrease from this point. So this shows you the phase of 90 degree shift, and a sine wave with phase of 90 degree shift is to the left by 1 by 4 cycle. So you can say t by 4 shift. If t is the period of the signal, it will be t by 4 shift in the left side if there is 90 degree phase shift. And here this is a sine wave with the phase of 180 start at time t0, and here the time amplitude is also 0, but at this point amplitude is going to decrease, and in the initial time 0 amplitude 0, but the amplitude is going to increase from this point, but here the amplitude is going to decrease at this point. So this is the phase of 180 degree shift, and you can say there is 180 there is t by 2, or you can say half cycle is shifted in the left side if the phase is 180 degree. So one example, a sine wave is offset 1 by 6 cycle with respect to time 0. What is its phase in degree and radian? We know one complete cycle is 360 degree, and 1 by 6 cycle, it means 1 by 6 into 360, or you can say 60 degree, or this 60 degree can be converted into radian by multiplying 2 pi by 360, or you can say it will be 1.046 radian. Now we will discuss about time and frequency domains. A sine wave is defined by its amplitude, frequency, and phase. And what we have shown in time domain plot, the time domain plot shows the change in signal amplitude with respect to time. To show the relationship between amplitude and frequency, we use frequency domain plot. The frequency domain plot is concerned with only the peak value and the frequency. Change of the amplitude during one period are not shown. And just like here, in 1 second there are 6 cycles are completed. So the frequency is 6 hertz, and the peak value of the amplitude is 5 volt. So in this is a time domain representation. On x-axis it is time, and on y-axis this is amplitude. So here frequency is 6 hertz and amplitude is 5 volts, and in frequency domain we consider only the peak amplitude. So we can have the frequency domain plot. On x-axis this is frequency, and on y-axis this is amplitude, peak amplitude, and frequency 6 hertz, the peak amplitude is 5 volt. Here you can see that complete sine wave in the time domain can be represented only single spike in the frequency domain. The frequency domain is more compact and useful when we are dealing with more than one sine waves. For example, this is one sine wave having frequency 5 Hz, means in 1 second 5 cycles are completed. Another frequency signal, it is a 15 Hz frequency signal, means in 1 second it has completed 15 cycles. And third one is having the frequency 0, and the amplitude of maximum amplitude of all these three signals are 5, 10 and 15. So this is the time domain representation of three sine waves with frequency 0, 5 and 15. All these three can be represented in frequency domain by three spikes. Just like at 0 frequency, the amplitude is 15. So for the 0 frequency signal, the amplitude is 15. And for the signal having frequency 5 Hz, the amplitude is maximum amplitude is 10. And for the frequency signal having frequency 15 Hz, the amplitude, maximum amplitude, peak amplitude, it is 5. So there are three spikes in the frequency domain. The signal, which is composed of many simple sine waves, is known as composite signal. So this is composite signal having three different sine waves. And a French mathematician, J. Fourier, in 1990s shows that any composite signal is actually a combination of simple sine waves with different frequencies, amplitude and phase. A composite signal can be periodic or non-periodic. If the composite signal is periodic, then the decomposition gives a series of signals with discrete frequency which have a integer value. So here you can see here this is the periodic signal, or the composite signal having the periodic signal. So they are discrete values in the frequency x on x-axis, in the frequency discrete integer values. And if the composite signal is non-periodic, then the decomposition gives a combination of sine waves with continuous frequencies. So in that case, the frequency domain having the continuous frequency, and the bandwidth of a composite signal is the difference between the highest and lowest frequency contained in that signal. So bandwidth, it will be actually component of highest frequency component and lowest, difference between highest frequency component and lowest frequency component. Now the propagation time and wavelength. Propagation time is the time required for a signal to travel from one point of a transmission medium to the another. Time t is distance by speed, propagation speed. Wavelength is another characteristic of the signal traveling through a transmission medium. Wavelength binds the period or the frequency of a simple sine wave to the propagation speed of the medium. Wavelength is the propagation speed into period, or you can say propagation speed by frequency, or you can say lambda is equal to c by f. Just like here you can see, this is the sine wave at time t, and this is the direction of propagation. And after passing one wavelength, or you can say after passing one period, or you can say peak to peak distance, is basically the wavelength, and this is at time t plus t. Now we will discuss transmission impairments. The signals travel through the transmission medium which is not perfect. The imperfection causes signal impairments. This means that signals at the beginning of the medium is not same as the signal at the end of the medium. There are three causes of impairments: attenuation, distortion, and noise. Attenuation means a loss of energy when a signal, simple or composite, travels through a medium. It loses some of its energy involves in overcoming the resistance of the medium. That is why a wire carrying electric signals get warmed. And to compensate for this loss, a amplifier can be used to amplify the signal. As you can see in this figure, at point 1 this is original signal, and when the signal propagate from point 1 to point 2 there is attenuation, and so the attenuated signal, this at point 2 is here, this is attenuated signal. And if I'm going to use amplifier to compensate for this attenuation at point 3, my amplified signal is like this. So the unit that we use for the attenuation is decibel, dB. It measures the relative strength of two signals, and dB means 10 log 10 power at point 2 divided by power at point 1. So I'm going to find out the power at point 2 compared to at point 1. And you know the power is proportional to voltage square, power is proportional V square, so I can write in dB it is 20 log 10 V2 by V1 if in case of voltage is given. So for example, let the energy strength at point 2 is 1 by 10th with respect to the point 1, and let the gain is 100 times at point 3 with respect to point 2. So find the attenuation at point 2 in dB and gain at point 3 in dB with respect to point 2, and the gain at point 3 with respect to point 1 in dB. So here at point 2 the power the strength is 1 by 10th with respect to the strength at point 1. So attenuation at point 2 in dB, it will be 10 log 10 1 by 10, because at this point if power is 1, at point 2 the power is 1, if at point 1 power is 10, so 1 by 10th is here, and it will be minus 10 dB, and minus indicate or represent this negative sign represent the loss of the power. So 1 by 10th, if at point 2 it remains 1 by 10th power, so the attenuation is basically minus 10 dB. On the other hand, let the gain is 100 times at point 3 with respect to point 2. So then the gain at point 3 as I compared with respect to point 2, it will be 10 log 10 100 by 1, because at point 3 the gain is 100 times compared to 1. So it is 20 dB. So here gain is represented as plus and loss is represented as minus. And this total gain, if I compare with respect to point 1 and point 3, so at point 3 the total gain with respect to point 1, it is the loss is minus 10 and the gain is plus 20. So I am having 10 dB gain at point 3. So now we will discuss distortion. Distortion means that the signal changes its form or shape. When attenuation occurs, all frequency component attenuated uniformly. However, it does not happen in practice. It has been found that attenuation of all frequency components are not same. Some of frequencies are passed without attenuation, some are weakened, and some are blocked. This leads to distortion. And that is what we are sending, receiver not getting the same thing. So here using the with the distortion we are having the spread signal, and this will cause the intersymbol interference at the receiver side. Now this distortion can be decided by the bandwidth of the channel or medium. Noise is another cause of impairment. So far we have neglected the effect of noise. There are several types of noises that may corrupt the signal: thermal noise, induced noise, intermodulation noise, crosstalk, impulse noise. Random movement of the electrons at cool leads to thermal noise. This noise in wire creates an extra signal. The induced noise comes from motors, appliances, devices, acts as transmitter antenna, and medium acts as receiving antenna. The intermodulation noise occurs when signals of different frequencies share the same medium and creates non-linearity in the transmission system. The unwanted coupling between two medium creates crosstalk. For example, in telephone networks, a number of cables are bunched together and sent from one place to another. The signal passing through one cable induces a signal in another cable, and this leads to crosstalk. In our telephone network, the crosstalk is a daily phenomena. That is, we can hear unwanted talk. The impulse noise arises due to disturbance such as lightning, electrical sparks. This is not getting generated in the medium, but the environment generate it from electric spark, welding, turning off on switches, etc. So this is the end of this lecture. Here we have discussed about what is signal, characteristics of the periodic signal and transmission impairments. This was lecture 4th of the lecture series of Basics of Communication Engineering. Till now we have discussed the introduction of the communication system. From the next lecture we will start discussion about need for modulation technique. Till then, thanks for listening this lecture. Thank you.